All right, ladies and gentlemen, these are notes 13B. I will be going over the first two examples, box 1 and box 2. All right. So if you guys need time to set up your notebook, go ahead, take a few minutes. You guys can go ahead and pause the video. I am going to be working on, like I said, box 1, which is this one, and box 2, which is this one. You guys will have a separate link for box 3 and 4. Don't forget to copy your notes title and objective over here on top. Again, if you guys need more time to set it up, go ahead and pause the video. All right, so in box 1, you guys have the question, is it a function, right? And the other day I spent a few minutes showing you guys how we can represent a function, and we can use a table, right? We can use mapping, we can use a graph, and we can use ordered pairs. Just different ways to represent our data, okay? So right now, the first one I'm going to be doing is the mapping part, okay? When I do the mapping, the left figure represents your input, which is your X, and the right figure represents your Y, which is your output, okay? Now, when you write these numbers, you're going to write them in order from least to greatest, right? So I'm going to start off with my input. From least to greatest, I have -4. Okay, so I'll put an X just so I know that I did that one already. Then I have -3. All right. See how I have -3 again? I do not have to rewrite it. I'm just going to put an X on both of them. That's letting me know that I already wrote it. Then I have 0. Then I have 1. And finally, I have 5. Okay. Now, I'm going to go ahead and also for the Y, or my output, or for the f of X, I'm going to list them from least to greatest. So I'm going to start off with -6, -3. Then I have 0, and even though 0 repeats, I'm only going to write it once. So I have 0, and I'm going to put an X on my 0. Okay. Then I have 2, and again, even though it repeats, I'm only going to write it once. So now that I have them written, the next thing I'm going to do is I'm just going to write arrows depending on what number they correspond to. So, for example, -3 goes with 2. So I'm going to put -3, and I'm going to draw an arrow going to 2. 5 goes with 0. So I'm going to draw an arrow from 5 to 0. Then I have 1 to -6. So I'm going to draw an arrow from 1 to -6. Then I have -3 and 2. So even though I already have it, from -3 to 2, I don't have to write it again. And then I have from 0 to 0. And finally I have -4 to -3. So -4 to -3. Okay? So that's how we do mapping. The next one that we're going to do is going to be, and I'm actually going to do ordered pairs first before I do the graphing. Ordered pairs, we're basically going to put the numbers that we already have in the table as parentheses. So we're going to do -3, comma 2. Then we have 5, comma 0. Then I have 1, comma -6. Then I have -3, comma 2. Then I have 0, comma 0. And -4, comma -3. That's my ordered pairs. All I did is I put them with X and the Y next to each other inside parentheses. And the last thing I'm going to do is I'm going to graph them. Okay, so I'm going to start off with negative 3 and 2. So I have negative 3 and 2. That's my point. The next one I have is 5 and 0. So 5 and 0 would be right here. The next one I have is 1 and negative 6. 1 and negative 6 would be right here. Then I have negative 3 and 2. I already have it there, so what I'll do is I'll put a small dot, different color, on it because it repeats. And then I have 0 and 0, also known as the origin. And then I have negative 4 and negative 3. So negative 4 and negative 3 right here. So that's how we do the table, mapping, ordered pairs, and the graph. Now, we still haven't answered the question, is it a function? All right, is it a function? And in order to determine if something is a function, we have to look at the x values, okay? So everyone has their strategy, everyone has what they want to look at first. I honestly like to look at the table. So if I look at my table, all right, do any of my x values repeat? And in this case they do. We have that negative 3 repeats right here and here. But because it repeats, it does have the same output, and that's okay. So even though it repeats, that's fine. So is this a function? Yes. And you can say because every x value has a different y value. Okay. Now, if you're thinking, wait, Mr. Franco, but this one doesn't have a different one. It doesn't. I know it doesn't. It's the same one, but it's also the same x. Okay. So if they repeat, if the x values repeat, the only way that it's acceptable and it's okay is if they have the same output. In this case, they do. Okay. They both have 2 and 2 as the output. So this is a function. All right. Going on to the next one. Same type of problem, right? I'm giving you guys a table. We're gonna go ahead and do the mapping, do the graph, do the ordered pairs. All right. So again, same thing for the mapping. The x values, again, go on the left. The y values or the outputs go on the right, from least to greatest. So for my x, I start off with negative 5. So I'm gonna cross that one out. And then I go with 0. Cross that one out. Then I go with 1. Cross that one out. Right? Then I go with 3. Even though it repeats, I'm only going to write it once. And last but not least, I have 6. Okay. Now I'm going to go ahead and do my outputs, or my f of x, or my y values. So I have, again, from least to greatest. So I have negative 5. I have negative 2. Even though it repeats again, I'm only going to write it once. I have 0, 3, and 7. Again, I'm going to pair them up. I'm going to draw arrows, so the negative 5 goes with the negative 2. So negative 5 with negative 2. 3 goes with negative 5. So 3 goes with negative 5. 0 goes with 3. So 0 goes, 0 goes with 3. Right? And then I have 1 goes with 7. So 1 goes with 7. 6 goes with negative 2. So 6 goes with negative 2. And then 3 goes with 0. 3 goes with 0. So that's my map. Okay. Now I'm going to go ahead and write it as ordered pairs. So let me go ahead and set it up. So my first ordered pair would be -5 comma -2, 3 comma -5, 0 comma 3, 1 comma 7, 6 comma -2, and then 3 comma 0. All right, so those are my ordered pairs. Again, if you guys are wondering how I did that, I just put the numbers next to each other, these that are on the table. Okay, let me go ahead and delete that. Now all I'm going to do is I'm going to plot my numbers on the coordinate plane. All right, so I have -5 and -2. -5 and -2 goes right here. 3 and -5. 3, -5 goes here. 0 and 3 right here. 1 and 7 over here. 6 and -2 goes right here. And 3 and 0 goes right here. Okay, so that is a graph. Now the question is asking us the same thing as the last one. Is it a function? All right, now as long as your x values don't repeat, if they're all different, it's a function. But if you guys notice, we have 3 here and 3 here. And again, the only way it is okay is if they have the same output. And if you guys notice, they do not have the same output. So no, because 3 has 2 different outputs. And those different outputs would be -5 comma 0. Oops. I wouldn't put it in parentheses. Okay. Now if you're wondering, wait, Mr. Franco, how would I recognize that under the table? Well, if you're looking at the table, look at 3 right here. And it's a little bit confusing, but you see 3 pairs up with -5, and then we also have 3 going out with 0. So that's why it didn't work. Now if you're looking at the ordered pairs, let me do it in purple. If you're looking at the ordered pairs, you see this one right here, 3 comma -5, and then we have 3 comma 0. That first value represents the x. That number cannot repeat, and if it does repeat, the only way it's okay is if it has the same output. Now, if you're thinking, wait, how do I recognize it on the graph? Look at the graph. If I draw that vertical line, you see how it passes 2 points? The first point that it passes through is going to be 3 comma 0. That's this point. The second point that it passes through would be 3 comma -5, and that can happen. Okay, so that makes it not a function. All right, so this is example 1 and example 2. I will show you guys 4 more examples. I'm going to show you one of each individually, and we're going to determine if it's a function or not a function. Okay, you do not have to copy the next examples. It's just extra practice. If you guys get it already, then you guys can stop here. You already have your 2 examples, you're good. But if you guys need extra examples, just pay attention to the next 4 boxes. Again, you're only paying attention to the next 4 boxes. Do not copy this, just like it says up here. Do not copy this, but we're going to answer this question. Is this one, is it a function? All right. Now, everyone does it differently. Some people will look at it and automatically say, no, this is not a function, or yes, this is a function. The way I like to do this, I focus on my x-axis, right? This is my x-axis, the one highlighted in red. Because I told you, that cannot repeat. You cannot have a number that is along that is the same x value. So if I look at the first x value, you see this one going up, that is just -6. That's just the x value, okay? This x value going down is -3, okay? This x value stays there, and that is -1. This one stays there, and that is 0. This one going back, that is 2. And this one going down, that is 3. This one going up, that's 5. Again, I'm only identifying the x values. Do any of my x values repeat? That means, do I have any of these numbers that are exactly the same? If your answer is no, then that means this is a function. Yes, this graph represents a function. All right, this graph represents a function. Now, let's just say hypothetically there was a point right here, right? You guys see that one in green and light green. If that point was there and you go straight down, that also has a 5, then that would make this not a function, okay? Because there's 2 points that have 5, and it's the ones that I'm putting in that blue box, okay? That is assuming that I added that last point there, okay? But let me remove it, because as of right now, this is a function because all the x values are different, okay? All right. Again, you do not have to copy this one. This is just extra practice if you're having issues understanding the concept. If you already get it, you don't need to continue with these examples. All right. The next example, I'm giving you ordered pairs. All right. So if you guys pay attention to the ordered pairs, the first number represents your x, and the second one is your y. Let me write it in white. X and y. 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 We're focusing on the x values. We do not want the x values to repeat, right? Now, if you look at the ones that I underlined in green, do any of my x values repeat? And if your answer is yes, you are correct. We have -2, 1, right? And we have -2, 3. My x values repeat. Since my x values repeat in both of these, and they don't have the same output or the same y value, meaning one of them is a 1, one of them is a 3, that makes this not a function. Okay? Not a function because they have different outputs. Okay? And this was showing you with ordered pairs. All right? Next one. Again, you do not have to copy this. This one is the one that people find the most confusing. And this one we call a mapping or a map. Okay? Now, the numbers are put in order from least to greatest. What I like to do when I see this, I actually like to write them as my x and my y table. Okay? So I'm just going to write my x and my y table. And make my table a little bit better. So I'm going to start off with the first one, okay? As I complete them, I'm going to go ahead and just draw a line, just a red line letting me know that I did it. So I have -7 and -6. So -7 and -6. Why did I put these together? Because that's where the arrow's pointing. Then I have -2 and -6. -2 and -6. The next one I have is 0 and 0. 0 with 0. And I also have another line going from 0 to positive 4. So from 0 to positive 4. Then I have one going from 3 to 1. So draw 3 to 1. Then I have one from 4 to 4. Okay. And then I have one from 11 to 4. Now, is this a function? And if you guys notice, we have 0 and 0 here, and we have 0 and 4. This input, or this x value, has two different outputs. So no, this is not a function, because for this one input has two different outputs. Kind of like the soda machine, right? You guys remember the soda machine? So if you guys press on the slurp button, you should be getting whatever the outcome you get the first time, you should be getting that outcome over and over again. You shouldn't be getting something different. So it has to be consistent and predictable. All right. One more example. Last example. Okay. So right here we have a table. Like I told you guys, I like tables. I always write everything as a table. I don't necessarily put them in order from least to greatest, but I write it as a table. And if you guys notice, in order for it to be a function, none of the x values should repeat. And if you look at it, none of them repeat. So is this a function? Yes, it is a function, because none of the x values repeat. Now, if you guys are wondering, wait, Mr. Franco, what about the y values? That's fine if they repeat. They can repeat however many times they want. They can have different x values that they're paired up with. Doesn't matter. What matters is that your x values don't repeat. Now, the only way it's okay if an x value repeats, right? Let's just say that hypothetically you have a negative 7 here. Then this must be 2. Why? Because you already have negative 7 here with 2, and you have negative 7 with 2. That'll still make it a function. That is still okay. Now, let's just say that I actually decided to change that number, and I told you we have negative 7 and 3. Since we have negative 7 with 2 and negative 7 with 3, it's not the same output, right? That 2 and 3 are not the same. This would be not a function, okay? So keep that in mind. All right, ladies and gentlemen, if you guys have any questions, please don't forget to ask during class. Again, the last 4 boxes were only examples for you guys to pay attention and follow along. You did not have to copy like the note says it up here.